let's go over these three problems where you have to use all the information that we talked about. And I still have it here, so we can go back to it and reference it to be able to answer these questions. So let's look at the first question. It says, hold on, I want to read it in a Frankie voice.
A teacher writes the following numbers on the board. -11, 0, 7, 2/3, and -4.5. From this list, identify which numbers fit into each category below.
I don't know why I used that voice. Maybe because it's close to Halloween. All right, so we have -11, 0, 7, 2/3, and -4.5. And we have to tell which one of those numbers are whole numbers, integers, natural numbers, and rational numbers. So let's take the first number. All right, so we have -11. So if we look back here, we know that all negative numbers are included in the integers group, but are not included in the whole numbers or in the natural numbers. But they are also included in the rational numbers because they're integers. So -11 is here, it's in the integers because it's included here and in the rational numbers. So when I'm answering that question, I have to put -11 right here in the integers, -11, and in the rational numbers, -11. But I cannot put it in the whole numbers or in the natural numbers because neither of those groups include negative numbers. So let's go to 0. Aha, 0, we learn it's not used to count, right? Because remember, they had to make another group for a 0. So 0, it's included in the whole numbers. So let's put it here in the whole numbers. And it's included in the integers. And it's included in the rational numbers. Because again, if we go back here, we have 0 included in the whole numbers, included in the integers, and because the rational numbers include the integers, 0 is also a rational number. Okay, we're cooking. Now, we have a 7 here. 7, it's a number used to count. So it is a natural number, boom. But if it's a natural number, other than 0, it's also a whole number. And it's also an integer, and it's also a rational number. So 7 goes into every single category because it's a number used to count. It is a whole number because whole numbers include numbers used to count. It is an integer because integers include natural numbers, and it is a rational number because then again, it includes them. Now, 2/3 is a fraction. And if you remember the story, they had to create the last category to be able to talk about fractions and decimals. So 2/3 goes into rational numbers because they had to create rational numbers to talk about fractions and decimals. But it's not an integer, and it's not a whole number, and it's not a natural number. And finally, we have a decimal that is negative. A decimal that is negative. So this is interesting because if you see that negative there, you might be tempted to say, oh, it's an integer because integers include negative numbers. But you would be mistaken because it's a -4.5. And the only group that includes decimals is the rational numbers, even if they're negative. So -4.5 goes into rational numbers. 4.5, but it cannot go into the integers group because integers do not include fractions and decimals. All right, so you need to do a lot of these to be able to kind of get the swing of it. All right, but if you start by memorizing the story that I told you, which is completely true, true story, based on a true story, inspired by a true story. Anyway, you'll be able to answer these questions. Okay, so let's look at the next question. Which of the following statements is true? Okay, so one of them is true, 3 are wrong. We have to evaluate each one of them carefully. Let's go to 8. All natural numbers. Okay, what are the natural numbers? The ones used to count. 1, 2, 3, 4, but not 0. All natural numbers are also whole numbers. All natural numbers are also whole numbers. Let's go back here. All natural numbers are also whole numbers. Yes. Okay, so far so good. All natural numbers are also whole numbers, but not all whole numbers are natural numbers. All natural numbers are whole numbers, yeah, but not all whole numbers are natural numbers. That's correct, because whole numbers include zero, and zero it's not. Okay, so that one is looking like it's true. That one is looking like it's true. So let's put a question mark here. Okay, it says all integers are whole numbers. All integers are whole numbers. No, because integers include negative numbers, and negative numbers are not in the whole numbers group. So that's fake. That's false. All right, so let's go to the next one. So we know this is false for a fact. A rational number can never be an integer. Ooh. A rational number can never be an integer. Wait, if I have a fraction and a decimal, yes, that can never be an integer. That's true. But rational numbers include integers. Hello?
Hold up. Wait a minute. Something ain't right.
So, if rational numbers include integers, then all integers are here. What do you mean that a rational number can never be an integer? All integers are rational numbers. So, duh, yeah, it can. So that is false too. That it's false because integers are included in rational numbers. And the fact that it says can never be an integer, that's wrong, because integers are part of rational numbers. And then 0 is a natural number. Ooh, remember the beginning of the story? 0 was not included in the natural numbers because 0 is the absence of an amount. So they had to create the whole numbers to include 0. So this is false. So the actual true statement is A. All right, last question. It says, a scuba diver is exploring underwater. The surface of the water is represented by a 0. Okay, so I'm going to do my little drawing. Those of you who were my students, you remember that I'm all about drawing. So this is the surface water, okay? And this is 0. And here's my scuba diver. Boop, boop. Let's do the flippers. Okay, that's my scuba diver. Let's snorkel and the mask. Okay, that's my scuba diver. And the surface of the water is 0. The diver is at a depth of 20 feet below the surface. So he's here, 20 feet. Feet below. So if this is 0 and he's below, mathematically, that 20 would be a negative number because amounts less than 0 are negative. Okay, so he's at minus 20 feet. All right, so remember, all numbers here are positive and all numbers here are negative. All right, the diver is at a depth of 20 feet below the surface. Later, the diver rises 15 feet. So he goes up 15 feet. 15 feet. So even if he went up 15 feet, he's still not at 0, right? So, this is interesting. Where is he? Where is he in terms of numbers, right? When he rises 15 feet. So he was at minus 20, but he went up 5, 10, 15 feet. So if he's here now, where is he? He is at minus 5 feet because he needs 5 more feet. He needs to rise 5 more feet to get to 0. So he is at now on the second here, he is at minus 5 feet. Let's answer the following. Okay, we understand the story now. We know what happens. So let's answer the question. What is the diver's final depth as an integer? As an integer. So remember, integers include negative numbers. And we just said that he was at minus 20 and he went up 15 feet. So he's at minus 5. So the answer to that question is he's at minus 5 feet. And I used minus 5 here. Is minus 5 an integer? Yes, it is, because integers include negative numbers. All right, so we have that one down. Explain why this final depth is an integer, but not a whole number. Aha. So if somebody answers, hey, he's at 5 feet. He's at 5 feet after he rises 15 feet. They would be wrong because they just gave me a positive number, and positive numbers are above the water level. So that means that he would be outside of the water, and he's not outside of the water yet because he was at minus 20 feet and he went up 15 feet. So whole numbers include 0 and all positive numbers, but they do not include negative numbers. So when I say he's at minus 5 feet, I have to say that minus 5 is an integer and not a whole number, because whole numbers do not include negative numbers. Boom. And if I answer that he's at 5 feet, not at minus 5 feet, I would be wrong, because I would be saying that he's outside of the water and he hasn't come out of the water. So anyway, I just wanted to give you these few questions so that you understand how these categories of numbers can be used on a test. And I hope that this clears it up. Now, I talked about a bunch of videos on YouTube that explain these maybe even better than I did. So I'm gonna link one of those videos that I really like on the description of this video and video number 1. Okay, so to whomever asked for this video, thank you for watching my channel and keep it coming. See ya.